Hello everyone, this is Vinay and welcome to my YouTube channel. In this video, we'll be looking into Numpy. You might have heard about Numpy. So what is it is a open source library in Python, and this is used a lot in artificial intelligence, data science, machine learning, all these domains. So what it stands for is it is numerical Python, NumPy. Why do we need these library? So major thing is, first one is it is very fast. Second is it has lot of handy features that we need to use during our coding. So let us stick to this and start understanding the code of NumPy. To start with NumPy, we first need to install it. We can install it using pip install NumPy. So this is already installed in my system. Now let us create a Jupyter notebook. So we have now created this Jupyter notebook, and the first thing that we need to do is import the NumPy package. This is how we generally use NumPy. A lot of codes you'll see that they import NumPy as NP because it is easy to write, but you can directly import NumPy as it is. Let us do this now. So we have imported NumPy. Now the major thing about NumPy is we can easily deal with any kind of array operations. So that will come across as we write some more code about it. But let us see how it is similar to our native Python list. So let us take a normal list in Python. I'm just creating one list out of nothing, or we can just simply use a random list, and let us take a NumPy list. So this is how we declare our normal list, and this is how we declare our NumPy list or NumPy array. In this case, we have used the same elements as the normal list, so we can directly pass this normal list variable to our NumPy list. Let us run this code. Now let us let us see the type of these both lists. So type of normal list and type of NP list. So you can see here is this first variable normal list is a Python list, and this other NP list variable is a numpy.nd array type of object. So let us create some large lists. Let us take a normal list again, and this time we take a large list. So how we can get that is, let us create from a range. Okay, so this is our normal list, and we just convert our normal list to NumPy array also. So we have created these two lists. If you want to see the output of both, we can use this normal list. So you can see that it goes all the way till a very large number. So it will go to this 1 lakh, and same is for NP list. It is just that it is a NumPy array instead of normal Python list. Now let us try to see how we can leverage NumPy for our use. Let us try subtracting 1 from each element. So in our normal Python list, we have multiple options. What we can do is we can use list comprehension. We can also use like normal loop method, and we can also use NumPy method. So we'll be using time, percent time to calculate time required for each method mentioned above. So let us try with normal list comprehension method. So what we can do in this case is a equals x minus 1 for x in normal list. So we are taking each element at a time as x and setting it as x minus 1. So we get 1 subtracted from each element. So in this case, you can see that the wall time is 23.3 milliseconds. Now let us try with loop method. In this method, let us take just empty list, and for x in normal list, we just append x minus 1. Let us try to run this code also. So this is taking around 54.8 milliseconds. Now let us come to our numpy method. So what we need to do in numpy is we just simply need np list and just subtract 1 as it is. And you can see that the wall time here is 10.8 milliseconds, which is very, very less than this list comprehension method and loop method also. As the list or the array becomes larger and larger, you can visibly see there is a lot of time difference between the execution of each method. So this is how it is. NumPy is very fast and also easy to code. Now let us try to understand the indexing of NumPy arrays. Let us create a normal NumPy array. Let us say just take random some numbers. So this is our NumPy array at this moment. Now, how do we get the first element, the fourth element, or the last element out of this list or NumPy array? So it is very similar to what we use in normal Python list. So let us say that we want to get the first element. So let us just write like this: first, then say third, then last, second, last element. We want to get these elements. So what we can do in this case is we need to understand the indexing first. So to understand the indexing, I'm just writing the indices here. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So these are the indices. So this is the zeroth index. This is zeroth index, or this is also the first element. This is first and this is last. This is second. You can see that there are 6 elements in total, and index start from 0 to 5. So that is 0, 1, 2, 3, 4, 5. Now let us try to get these elements. So how do we get first element? So a of 0, because it is zeroth or zeroth index, that is first element. We want to get third, so that means that a of 2. When we want to get the last element, we can simply use a of either 5, or we can simply use the negative indexing as -1. And second last element we can easily get using -2. And let us try to run this code. In this case, you can see that the first element is 3, third element is 2, last element is 8, and second last element is also 8. Now this is very easy for a normal array. But what if we get a multidimensional array? So let us take one multidimensional array. So what it means is it has rows and columns. So let us take 2 dimensions. So let us see this: 2, 4, say 5, 6, and let us say 5 again, and 9. So these are some random numbers, and I'm just creating numpy array out of it. So in this case, you can see that we have obtained this numpy array. So we first need to understand these multi-dimensions. So when we work with normal two-dimensional arrays, we have we have first rows and columns. So these are rows. So these are rows, and these are columns. Okay, so that means that this is the first row, this is second row, this is third row, this is first column, and this is second column. But the indexing, as you know, always starts from 0. So that means the index of first row is 0, 1, 2. So this is index. And in this columns also, it starts from 0 and then 1. So now what if you want to get a particular row elements, or maybe just a single element? So let us try to get this 6 out of this array. And after that, let us try to get, let us say, this 5 and maybe the whole second row also, and this second column also. So we try to get these four things. So what we need is, we need element from second row and second column, so that is 6. We need to get third row and first column, that is 5. We need to get whole second row, let us get whole second column. So this would be around, so whole second row is 5 comma 5 comma 6, and the whole second column is, it contains elements 4, 6 and 9, but in column format. So how do we get these? So to get second row and second column, what we need to do is a of, so second, that means the index is 1, and we use comma and pass the column also. So in this case, you can see that this first index is for row and the second index is for column, or you can rather say that this is for first dimension, this is for second dimension. If your array was of say 3 dimensions, then we could need another index here. So if it was of say 3 dimensions, we can write again using some comma and mention the index. So let us try this code, and you can see that it outputs 6. So that is correct. Then we want to get third row and first column. So what it means is a of 2 and first column is 0. Then whole second row is a of 1 and whole second column is, what we want to do is, we want to get all the rows and we want to get the second column, so that means 1. So in this case, you can see that we get all the things we need. So this is 6, first thing is 6, second thing is 5, then we get the whole second row, that is 5 6, and then we get the whole second column, that is 4 6 9. Now you might ask, what is this operator? So in normal Python lists also, and in Numpy also, we can easily use this. So this is generally used for slicing. So what it does is, we just need to understand a little bit of basics first. So this is a operator, and before it, we need to pass some start and end. After that, we need to pass end. So when we speak about start and end, so these are index. So this is one, start is index and this is also index. Now when we don't write anything, so that means that start from the very end, when we don't write anything like this. So like this operator, in this case also, we have not written anything in either of the side. So that means that start from the beginning and end till the last element. And suppose if we write say 1, and that is it. So let us say, so that means that for the rows, we start from the second row or the first index. So this is start. So you always know that before this comma, everything is for row, and this is for column. So now in this case, you can see that this is the starting point and this is the ending point. So ending point we have not provided, so that means that it will go till the last. Okay, this is going to last, and this is for second row, starting from second row or first index Suppose you want to get some elements till some range also, so you can easily pass some range. So a of, for columns, let us say you want to get from second row, you just need to start from second row and go to all the way, and you just need the column, let us say only the first two columns. So we start from the very start, and the first two columns is, so the first two column is 0 1 2. So these are third three columns, and first two columns are these 0 and 1. So we just need to pass 2 here. So whenever we need to pass this end index in side of the colon, we need to pass the exclusive index. This is exclusive and this is inclusive. So what it means is that we start from first index. That means it is included, but this 2 means we end before this. So that means that whenever we find this index 2, we stop it there. We don't include the column number, column index 2 in our case. So we just stop till here. You'll understand more as we write the code for this. So let us now try to take some range indexing. So let us just create one numpy array randomly. So let us take just a again, np dot random dot rand int, and we just need to pass from, let us say, 1 to 10. So this is start and this is end of the elements randomly, and let us take size as say 4 cross 4. Let us try to print it. So you can see that we have obtained random numpy array. Now let us work on our indexing. So let us say, so we know that this is 0, 1, 2, 3. So this is all about rows, and this is 0, 1, 2, 3. This is about columns. Now suppose if we want to get, let us say, this second row, but only these two columns. So we just need to get 6 comma 2 as our output. Let us try to also get these two columns. Let us then try to get maybe the last element probably. So I'm just writing it down here. So we need to get this 5, 5, 8, 6, 3, 7, 2, 8, and a 5. This is the last. So let us try to get this 6, 2. What we can do is a of, so that this is row number 3. So that means its index is 2. So we start there only, and we just need that. So second row we need, and the columns we need. So this is the second column and this is third column. So that means that the index is 1. We start from 1, which is inclusive, and exclusive is this. So that means that 0, 1, 2, 3. We pass 3 here, we get what we need, 6 comma 2. Now let us try to get the large portion, this 5, 5, 8, 7, 6, 2, 3, 8. So I'm just writing it as second and third columns. We need uh, both of them. So we can simply use a of, so we need all the rows. We just pass colon as it is, and we need second and third column. So that means that the index is 1, and till third column's index is 2, but the end index that we need to write is the excluding one. So that means we need to write 3 in this case also. So you can see that we get the second and third columns here. Now suppose if we want to get this particular element, the last, so what we can do is we can simply use a of, let us say, we just need to write -1, yeah, from last row and from last column. Let us try to see this, and we get the element 5 in this case. There is one more thing that you need to know for this colon operator. So we know that in the left side we write start, and in the right side we write the end. So these are index, but there is also one more thing, that you can pass one more colon which is optional, and you can write step. So in our case, suppose you have a numpy array of say 1, 2, 4, 7, 9, something like this. And what we can do is, so what this step parameter means is, By default, it is 1. So if we pass, let us say a of colon colon and 2, we'll get every second element. So the output of this will be 1 4 9, because we are starting from this, but we are taking step as 2, not 1. So the next we go here, then next we go here. Let us see this in practice. Let us just write one numpy array, 1 4. I'm just taking some random numbers, so here they are. And if I pass two colons and then step as 2, then we get 1 5 7. Here also you can say we are taking steps of 2. We can also take steps of 3. So in this case we get 1 6. So we start from here and we end here. We can also start from some other row or index. Let us say we start from second element or the first index. So we are starting and we're going till the last, and we are taking, let's say, step of 2. Then you can see that there is this 4. We start from here, then we take step of 2 6, and we go 8. So now that we have learned the indexing of NumPy, let us understand what all things we have learned. Let us go through them. So the first thing is, indexing is similar to Python list. So we can write, say, a of 0, a of 1. If you want to start from backwards, then we use negative value. So this is the last element, this is second last element, and so on. We learned about this slicing operator, wherein we can write the start index and end index, and along with that we can also write this step index, which is, this is not an index but the value of how much steps we need to take. It is totally optional. By default it is 1. And to access multiple dimensions, we can easily use a and the index of first dimension. So we write something like index of first dim, then for second, for third, and so on. So in respect to index, we can always use our colon operators. So that is it for this video. We'll learn more about NumPy in further videos. Thank you for watching.